Okay. We'll just jump straight to it, I think. We've been instructed to tell you to squeeze together, but it doesn't look like there are many people standing, so just see how it goes. We're going to tell a story, basically, of something that we did at work about a year ago. This is us. I'm usually a lot more grumpy, but the guy wouldn't stop taking pictures until I smiled. So I am front lead at the current project, which we are going to talk about. Francis he was a trusty minion, but he's now gone on to greener pastures. We are partners at Knirkefritt. We are a small consultancy in Oslo, and we do other fun stuff as well, but that's for another time. The project is called Easy. It's a payment solution for online merchants, as you can see. It's a Nets product. Probably all of you know Nets if you've paid for anything really in Norway or probably in Scandinavia. It's gone through Nets somehow. This is a fairly new offering that they have. It has multiple payment methods. The difference between this and previous models is that you don't have to have separate agreements with each payment provider. You used to, as a merchant, you used to have a separate agreement with Visa and another with MasterCard, and then one with Vipps and everything else. Now they have one agreement with Nets, and Nets handles all of it. The sort of killer feature here is that you are recognized across different merchants. So if you bought something somewhere using this solution and then you go somewhere else, we will remember your details.
Let's have a look at what it looks like in its current iteration. If I can. There we are. Is this the right one? Yeah. So this is our test shop. So this is just a shop that we use to integrate with the thing that we're actually building. So this is merely just a test tool, which is why it doesn't look all that polished and beautiful. So we can add a few things to our shopping cart. I'd like to buy a couple of Rubik's Cube. And we'll go to the checkout. And now it's loaded here. And this thing here, this iframe here, is what we're actually building. So everything else around is just for testing. So we can enter some kind of email. And then you don't know if you saw it, it goes quite quickly, but there was a spinner here. That's when we're trying to look you up to see if we know who you are based on your email and postal code, which we don't because I've entered something unique. And I'll just carry on filling out. And in the background now, we've now registered you on this particular payment, not as a consumer before you've paid, but you're now registered so that you don't have to do that explicitly, so to speak, with a button. It's just done. And we can pay. So we'll say a little pray to the demigods and hope that something more happens, which it did. And if we now go back to the checkout, and I haven't cleared the cart, so that wasn't a very good demo. I should have been remembered here now. That was fun. You should have been here. But let's move on.
Okay, so when I started a project many years ago, the PM told me the first day I arrived to just write down everything that seemed odd or that needed improvement, or yeah, and anything really that stood out, because he said in 100 days you're blind. I thought that was very good advice, so I've done that for all my projects since. And this is some of the things that I wrote down when I started this project. When I came on this project, the previous front lead, he had left a month prior, so there wasn't really any overlap. I had a day with him, but it was pretty much here is the thing, make it better. The feedback loop when developing was horrible. It took 40 seconds from you made the change until you could see it, which is, yeah. So that was the first order of business. I got that down from 40 seconds to 800 milliseconds, which is, yeah, a lot better, I'd say. But that doesn't really have anything to do with this story. The main thing was that it was huge. I mean, if you saw the thing at the demo, is really just the tiny thing in the iframe with a couple of forms and a button. It shouldn't be megabytes big, and yeah, it's also really slow. It was really slow when we started. The general consensus is that it took about 6 seconds for it to show on the screen, which is a serious conversion killer when you're trying to get people to pay for something to buy. In addition to that, it was quite hard to make changes, because you changed something one place and then you broke something a different place. There wasn't a consistent architecture, especially around state management. There were many different patterns and strategies in use at the same time, which made it a mess, really. So yeah, that was yeah, the main drivers for doing this conversion to React. The reason why it was Angular in the first place was that they just copied a project that somebody else did, and thus inherited the whole stack without really considering what it was and why they were using it, or if it would fit their problem. So yeah. But it was already in production. People were using this, so we had to do this in a way that we could still deliver new versions. It was a 3-week release cycle, so every 3 weeks we had to have a new version with new features, and so yeah, that was the challenge, really, how to change the whole stack while still providing value and releasing all the time.
So let's show a quick demo of almost where we started. I couldn't get the initial version to run anymore that is just Angular. So this version that we have here is where we've started porting small parts of the application to React, and we've thrown out System.js in favor of Webpack. So if we go, let's just clear the site data. And let's select Norwegian and buy some more Rubik's Cubes.
Yeah.
We'll get there.
Yeah.
It hasn't crashed.
Don't think so.
Yeah, there we go.
There we go.
So you see the point, right? It's, I mean, if you want to go buy something and this is your experience, then you're probably bored and
Or think that it doesn't work and you've gone somewhere else long before it actually loads.
what you also see here is that there are lots of padlocks, so this is really secure, right? And there's also a focus on the payment details, which, for you as a merchant, that may not be natural. So we switched that as well.
And you saw in our previous one, we did all the registration and payment details in the same window. Here we're recognized, but when you register, you have to go through a 3-step process. So you have to go through one form, and then you go to the next one, and then you go to the final one that we're seeing here, where you can actually enter your payment details. So it's quite an involved process, registering and actually getting to the payment details and fulfilling the payment.
So just to show where we started, sort of technology-wise, we use the bundle analyzer plugin for Webpack. So what you're seeing here is everything, but it's everything is relative in size to one another. So big things on the screen are big on disk.
So you can see in total we have almost 4 megabytes of code that is downloaded on the client. Of course, it will be a bit smaller when it's gzipped and stuff, but still a really, really large payload for what is such a small application.
Yeah.
So
And if you see the purple thing in the top right corner, that's
our code.
Our code. And if you look at the whole yellow thingy, that all of the left side is just Angular stuff and its dependencies. We have RxJS as well, which is for Angular. We have something
We have jQuery as well, which is quite big.
jQuery as well. But in the blue one in the middle there, we have Zone.js as well, which is an Angular dependency. So quite a lot of this is just Angular, and we're not really using a lot of it, so it seems very wasteful to use so much, to have so much code that we aren't really using. So conversion to React it is. What you need to consider when you are going from something to something else is what's similar and what's different. Try to find something that is sort of the same, and see if you can make the transition easily somehow. Both have the concept of components, which is really an area on the screen which has a defined responsibility. It may have some business logic behind it, or something else. It usually takes in some kind of state, does something to it, renders it out. But in order to go from Angular to React, you have to transition all of the stuff that the component does. And in our case, that means getting all the state into Redux. So an app, any app really, is a tree. You have a root component, and then you have major components, which themselves have smaller components, and yeah, you get these branches, and you have the leaves, which are the components at the end, where you don't have dependencies on yet more components. They don't have any children. So that's what we found out that we should do. We start at the leaves and just move inwards toward the trunk. Yeah, you can move. So the easiest thing to do is to take just the templates. Angular components have a template which is HTML with some funky syntax, which is what renders things on the screen. In React, you have the concept of presentational components, which is basically just a component that isn't connected to the store. You just feed it with whatever properties it needs, and it renders it. There should be no logic, no nothing. Just feed it with props and display it. And that's also a nice proof of concept, just to show that we can actually do it. So Angular looks like this. It has a template. So we just replaced the template with a React component, and we'll show you how that works.
So let's bring up just get the right one. So we've got a component here that hasn't been migrated. So we can see this is an Angular component. It has a template URL, which, sorry, let's see if we can, is that better? So we have this Angular component here that takes a template URL, which points to this HTML file here that has all of your various bindings and stuff, and when this then gets tied together and run, then it renders out the data. And we somehow need to migrate this template here over to React. So what we did was that we made this little utility here that takes in a component and an ID for a DOM element for the component to be rendered on. And then we just render the component and with the props that have been specified onto the container element. And if we go to a component that has been migrated, we can now see that this has, instead of a template URL, it just has a string here with an HTML element with an ID that we can then pass in to the function that I just showed here. So then we have our view that we've got here, and then we send in our props, and then it gets rendered. And you'll notice that there are several calls to render throughout the component, and it looks a bit messy, but that's because while we're doing this, we need to have control of when things are rendered. And when we're finished, then we can just use the React lifecycle to render things at the right time. But at the moment, we have to take care of all of that manually. And then the component itself here is just a bog standard React component, just a function that takes in props and returns out some stuff not connected to the store or anything.
Yeah, so what you lose is the automatic change detection. So yeah, we have to call render ourselves when something is changed. So that's what you lose, but it's worth it.
And it's only temporary.
So after doing this, we show that this works. We can do it. And it's actually faster already, which surprised me. But after I thought about it, it makes sense. People started coming over, and yeah, thumbs up. It's much snappier. Keep up the good work. This is yeah, going in the right direction. So, but yeah, we are still in production. So what we did here was going out to merchants and end users, the consumers. So and we also implemented new features while doing this. So everything is just moving along nicely. And by constantly delivering new code to production, it goes through all of the testing and all of everything, so that we could verify that everything was working. But now the hard stuff begins, because we have to start thinking about the state, because that's the biggest underlying problem here, that we don't really have control of the state. Angular doesn't really enforce a way of doing it. You can do it in several different ways, and that was what was done here. Maybe you can.
Yeah, I can elaborate a bit on that. We'll get to it soon and show how it actually was implemented, but it used something called NGRX, which is kind of similar to Redux, but instead of just reflecting data changes on a stream when the stream changed in the view, as you would do with a connected React component that reacts to props or coming in from the store as things change, then new actions were dispatched from the component. So you had these wild race conditions with like things updating and new actions being dispatched. And as we were changing things, then some parts of the application got faster, and then suddenly applications got dispatched in different orders than they were before. So it was really, really difficult to do this transition without constantly breaking stuff. And things did break now and then, but we got there in the end.
Yeah, the thing is that it was really hard to make new features, because you almost always broke something unintentionally, and it was hard to just even see how they fit together, because I mean some state was in NGRX, some was in a service somewhere, some was I don't know. I mean it was a mess. So we need to just get control of the state, use one pattern instead of many, and just basically get control. So what we did was that we dropped in a real Redux store. I mean, NGRX is an implementation of Redux for Angular, but we are going to React. So we put a real proper Redux store in there as well. So the two stores were running in parallel. Actions were dispatched to both. So we could see that the same state was going to both stores, and in that way verify that things were working as it should. So this is how it works. So if you're planning on doing this yourself on your project, this is where you need to pay attention. We created an Angular service, which was called we just called it the Redux Store Service. It gets NGRX injected into itself through Angular's dependency injection. It wires up a Redux store, and we wrote some custom middleware to just intercept the actions and pass them along to NGRX, because Redux and NGRX doesn't really talk to each other. So yeah, it just parrots whatever actions comes in to NGRX. And then the reason why this was an Angular service in the first place is that we can inject it into Angular components and expose the Redux store as a property. And what happens then is that in the Angular component, you dispatch through Redux's dispatch mechanism instead of NGRX, and our middleware takes responsibility for passing it along to NGRX again. So to get a state out of the store in the Angular component, you use NGRX, but to dispatch new actions, you use Redux. So the action lifecycle goes like this. It gets dispatched through Redux, goes to the reducer, then it gets picked up by our middleware, and it gets passed along to NGRX, which then runs it through actually the same reducer again. So both Redux and NGRX are using the same code for the reducers. So this
is, just let me close that. This is the Redux store service that we were just talking about.
No, there.
Hmm?
This
one, yeah.
Yeah.
So we can see here that we have made a map of all the actions that we want to intercept and what we want to happen upon interception. And it's quite a long list. And at the very bottom here, we have the actual middleware itself. So for each action that comes in, we check if that action is in the map of actions to intercept. And if it is, then we do what we want to happen. And for all of them, it's just forward to NGRX. So in this component here that is then taking use of that, we see that we inject a Redux store service here, and instead of calling this .store dispatch to dispatch actions when things happen, then we use our Redux store service .store dispatch instead, and then it goes through the life cycle that we just showed in the diagram. So here you can see an example of one of these totally crazy things here with like subscriptions that dispatch new ones, and oh.
Right. So this is something that we did over and over again for each component and each part of the functionality. So you need to really just focus on something that you want to transition, and make sure that you have control over all the state, and then do the change. So this is where we're at. You have an Angular component which renders stuff through React, and in order to get the logic from the Angular component to React component, you just wedge another component in between the two. And initially, that's just a very thin component that just parrots all the props along to the presentational component. But the difference is that this component is connected to the Redux store, and you can get the props out. So for all the logic that you want to move from Angular to React, just make sure you have the props you need from the store, and you just have to copy it over basically. So the Angular component is shrinking, and the middle component here is growing. So, but still, there were lots of state that wasn't in either store really. So we have to go through and just make sure that everything gets handled. Everything that's shared in any way gets handled by Redux. Another thing is side effects. I mean, in computer science terms, a side effect is just some observable effect outside of a function. A pure function takes something in, gives you something out, and it's the same every time. It doesn't change the outside world in any way. A side effect is something that isn't pure, that does make a change, and in any sort of useful application, you need side effects. So in Angular, you have a concept called effects, which really takes an action. It does something based on that action. It goes to a server, asks for some data, or it can do whatever really. And usually the output of it is one or more different actions which have the payload that you want. So it's really a separation of events and commands. An effect picks up a command. You want something to be done, and it does it. And the result of that is an event with a payload. No, go back.
Sorry.
From my previous experience, I've used Thunk, which some of you probably are familiar with. It's a similar concept in React. I had to look up what a Thunk really is. What does it mean? The word just means a function that is returned from another function. So, yeah, it's just a library for doing side effects in React. It wasn't a very good match because of how it's structured and how it works. So we looked at Redux Saga instead, which matches better. It's basically the same. We will show you the code in a bit. So this is where we are, right? And NGRX, after the action goes to the reducer, it goes to the effects. But that doesn't work very well for us because, as I said, what happens in an effect is that it does something and it produces different actions. But those actions won't be picked up by our Redux store. And that's the problem. So what we do, get rid of the effects, rewrite them into sagas, and the sagas, they dispatch new actions, and then it just starts all over again at the top there, and goes through the whole thing and goes to both stores.
I just got a small example here. So this is an example of an Angular effect and a Redux Saga for the same thing.
Can you zoom out?
I can try. Did that? So both of them handle and address add, and both of them result in a successful or failed action. One of them uses RxJS and does it that way. The other one uses a generator and does it like that instead. I find it easier to read the generator version, but both of them are, yeah, do the same thing and result in the same actions being dispatched.
So we're already here, and after going through all of the components bit by bit, we're left with just the root, and that's still just a component, but it bootstraps the whole application. So you need to just handle it separately. Just start it up in a different way. So that was a special case. But you just basically you just take a chainsaw to it and replace it with a React version. So what remains now is this.
And then we ate cake.
Yeah, that was a happy day. So if we look at the result,
we can see here, these are all, of course, in relative terms as well. But before we had 4 megabytes of code, not non-gzipped, and now we have 725K for the same thing with, of course, we've added new functionality along the way as well as doing the migration. So it's quite a big difference here.
So yeah, and also if you look at if you look on the screen and see how much of it is our code now
That's
compared to the old one, it's almost half the screen, but it used to be just a little corner up on the right there. So I think that's quite an improvement actually. And if we look at the size of our code as well, it's actually smaller than it used to be, even though we have added new features. And I think that's mainly due to the fact that we have cleaned up the architecture. It's not as over-engineered as it used to be. We do things in one way, and yeah. So the numbers are quite nice. Size reduction was 69%. We didn't stop there. We have removed other stuff that wasn't used as well. So we're now down to an 82% reduction, which is quite significant, I'd say. The startup speed after we got rid of Angular was reduced by 67%. Which is also very nice. We have made some recent changes that brings it down to 95. Remember, and that's compared to the 6 seconds that we started with. We measured it on an iPhone a couple of weeks ago to 300 milliseconds. So that's yeah, I think that's a huge improvement. And this is really how it should have been this whole time. But we got there in the end. There is less code to maintain. And the architecture is a lot cleaner. It's much easier for people to jump in and understand the code, reason about it, and figure out what they need to do to make the changes they want to make. We have lots fewer bugs. Because yeah, we don't have those crazy situations where you change something one place and then it affects something someplace else. So yeah, it's much easier to implement new stuff. The development speed is a lot faster. We deliver more features and they work, and we are a lot happier. And that's That's actually quite important. In my experience, a happy developer is a productive developer, and vice versa. If you're not very happy, then you aren't really producing much. So that's a very big point. Yeah, we actually raced through this this time. I gave this presentation a week ago, and I spent a lot more time. So we have time for questions if somebody has them. Yeah, in the back.
Did you use any of the React developer tools during the migration? The browser tools?
Yes, the question was. Pardon?
How do they behave during the migration?
Yeah, good question. The question is, did we use any of the React developer tools during the migration? And the answer is yes, we did. We used the Redux developer tools a lot, and that was really helpful because you can switch between stores, and you can see NGRX in there as well. And that's what we used to make sure that we had captured all of the actions and all of the state, because we could just switch between and compare. So you could see that you could see the whole timeline, which actions were going where, and what we were missing, and just make sure that the state was the same in the end. So that was really helpful. Yes.
What kind of Angular version did you replace?
The question is what Angular version did we replace? When we came on the project, it was Angular 2, but we upgraded it quickly to Angular 4, and then we had to we actually switched between Angular 4 and 5 to just get everything stacked right to make everything work together. So I can't actually remember if we did it on Angular 4 or Angular 5, because it was quite fiddly with all the packages and what worked and what didn't work. Yeah.
Did you have good test coverage before you started refactoring?
Question is, did we have good test coverage before we started the refactoring? And the answer is yes and no. We had good test coverage for all of the business code, but not for the rendering and the state
UI
management
stuff, yeah.
and stuff like that. But we had and still have browser stack tests, which go through every scenario, every functionality that we have, and tests the whole stack, front end through the back end. Yes.
Why did you choose this gradual migration strategy instead of just creating a React component and then replacing it?
The question is, why did we choose this gradual approach instead of just creating a React component and just putting it in when we were done with it? Is that, yeah, correct? The reason for that is that it looks very easy when we present it like that, but in reality, a lot of the functionality is quite complex. So the application wasn't structured very well. In addition, we had a lot of really big components, which did a lot more than just one thing. So we could transition some of the functionality in a component, and then we had to wait a while to do the rest, because that's connected to something else. So if the application had been structured properly, and a component had one responsibility, then we probably could have done that. But it was just hard to do it the way it was, and we didn't want to restructure the whole thing at the same time. Yes?
Saying that Angular is big and bad and React is good, it kind of seems like lousy motivation. Should everybody rewrite into React, or
Okay. The question is that we're saying that Angular is big and bad, and React is small and good, and that's a bad motivation for rewriting. Is that right? And the last bit was.
Should everybody rewrite it?
Should everybody rewrite? No, I don't think so. You have to look at what you're trying to do. What is your project? What is its purpose? What are you aiming for? And as we saw, what we are building is just a little iframe, right? It has to load quickly. It's not a lot going on. It's just a small little thing. It has to be fast. It has to just. You want people to just fill in the smallest amount of details that they have to, and then you push a button and you move along. In a bigger application where you have lots more going on, then the startup time might not be a problem at all. You may need all the other stuff that Angular provides, because it's a huge library that gives you a lot of functionality just out of the box. You don't have to figure out what packages you need and cobble them together and keep everything compatible and stuff like that. So it's I mean, if you're doing something else than what we are doing, if you need all of that extra functionality that Angular gives you, then Angular is fine.
Any
More
more
questions?
questions?
No? We're done?
Thank you for coming.
Thank you.